when you go around a turn, there is a maximum speed you can go before your tires start slipping and you go off the road and, off a cliff to your death. So what is that maximum speed, you might wonder? Okay, well, let's zoom in a little bit here. And I've got all the notes already written out because we're very time constrained. But imagine you're looking down on a car, and this car is just on a circular track. And it goes faster and faster and faster until it reaches the maximum speed it can go, and then the tires start to lose their grip on the road. Well, what if you know the coefficient of friction, coefficient of static friction, you can figure out what this maximum speed should be. So let's take a look at this car right here, and I drew a free body diagram of this car. So here's the free body diagram, drew a little car. Here's the road, and we've got gravity pulling us straight down, and we've got a normal force that's supporting the weight of the car. But I think you would agree, if you're going around a turn, you're going to have a sideways friction force on the car that's pointed towards the center of that circle. All right. So, well, what is this force of friction? Remember, static friction can be less than its maximum. So when you go around a turn, it's the force of static friction, but it's not the maximum static force of friction. But if you go a little, almost too fast, the maximum possible you can go around a turn before you start to spin out, well, then that force of friction, this maximum force of static friction, will be equal to that static coefficient of friction times the normal force. And I think you can see here that the normal force is just supporting the weight. So I just said normal force equals mg. Okay, so now we know what the force of friction. Now, if I sum the forces in the x direction, here's my x direction and y direction, and I made my x direction to the left because the acceleration is to the left. I can say, well, at least in the drawing, that I made. Well, what is that? That force of friction that force of friction is the only force acting in the x direction. Therefore, that force of friction is the net force on the car, and that net force equals the mass times the acceleration. But what kind of acceleration is on the car if it's going around in a circle at its maximum speed, but the speed isn't changing? Just the direction of motion is changing. Well, that is a centripetal acceleration. So you have the mass times, well, what is the centripetal acceleration? It's v squared over r. It's the speed squared divided by the radius of the turn. And notice that the mass cancels out. If the mass cancels out, well, that just means that a little car or a big car, if they have the same kind of tires, it's not going to really matter how massive the car is. That's why the speed limit is the same for a big truck or a little, a small car. And notice this, you get this little equation right here. Mu g equals v squared over r. And I can solve this equation for v. And it looks like it spells rug, doesn't it? V equals the square root of rug. But it's r is the radius, mu is the coefficient of kinetic friction, or static friction, sorry, and g, well, we're on Earth. So g is 9.8 newtons per kilogram, or meters per second squared, which is kind of interesting because if you were on Mars, if you were driving a car on Mars, you'd have to drive slower around the turn because you're going to skid off because g is less. The r would be the same, mu would be the same, but g would be less. I had never really thought about that before. Never really driven on Mars. before, so not that concerned about it right now. So by solving for the force of friction and saying, hey, the force of friction equals mu times the normal force, and the friction force is also the centripetal force, the force that's making the car go in a circle, we can figure out the maximum speed. Now, who would do something like this? Well, if you work for Caltrans and you're a civil engineer and they're building a road out there and this flat road has a nice curve on it, you can figure out, well, you would ask yourself, what's the radius? What's the minimum coefficient of friction I can expect? Like, what if it was raining, so the roads were wet, and you had bald tires, some old tires that didn't have much tread on them anymore? And what planet are we on? So if you know what planet you're on, what the minimum coefficient of friction, and R, you can figure out the maximum speed that you should even allow. But should you even allow that speed? You probably want to reduce it from there so that you have a safety margin. And that's how they come up with the speed limits around turns. You get off the freeway and it says 20 mile per hour, those tight little turns, you better drive 20 miles per hour. Because you'll see those skid marks that go off. Yeah. Those were people who didn't take physics, I think. Okay. Any questions? That is all.